Hi everyone. In this video, we are going to discuss about the Unit 2 in digital signal processing. The Unit 2 is infinite impulse response filters. First, we discuss about the structure for IAR. IAR means infinite impulse response. First, its structure has four structures. They are direct form structures, cascade form structures, parallel form structures, and lattice ladder structure. So the important one are direct form 1 and 2 and cascade parallel. These three forms are important forms in this structure of IIR. First structure is direct form 1. We have to start from numerator to denominator. We have to start the problem by solving from numerator. Numerator is 0 to denominator poles. In direct form 2, we have to start from denominator to numerator, where denominators are poles and numerators are zeros. Then third form is cascade form. Cascade form can be performed by using factorization method. And fourth form is parallel form. Parallel form can be solved by using partial fraction expansion. In cascade form, we are using factorization to solve the problems. In parallel form, we have to use the partial fraction expansion to solve the problems. Problems based on direct form 1, 2 and cascade parallel forms. Here given y of n is equal to minus zero point 0.1 y of n minus 1 plus zero point 0.2 y of n minus 2 plus 3 x of n plus 3.6 x of n minus 1 plus 0.6 x of n minus 2. Let first step is to take the Z transform on both sides. By taking the Z transform for the given y of n, we get y of z, where y of n is y of n, Z transform of y of n is y of z, and point 1 Z inverse y of z, where Z inverse here n minus 1. So here Z inverse. Then y of n's Z transform is y of z plus zero point 0.2 y of n minus 2 z power minus 2 y of z, then plus 3 x of n means x of z, then plus 3.6 x of n minus 1. Here z transform is 3.6 z inverse x of z, then for 0.6 x n minus 2, z transform is 0.6 z power minus 2 x of z, where z transform h of z is equal to y of z divided by x of z. H of z is a system function, where y of z divided by x of z is a system function, where then the y of z becomes y of z plus zero point 0.1 z inverse. So here we are transferring the y of z to left side and transferring x of z to right side. So then we get this equation by taking y of z as a common one. We are having y of z into 1 minus zero point 0.1 z inverse minus zero point 0.2 z power minus 2. Then here we are taking x of z as common. So x of z of 3 plus 3.6 z inverse plus zero point 0.6 z power minus 2. Then as a system function y of z divided by x of z, we get here we are taking this as here, then transferring this y of z is here. Here the y of z and this term is in multiplication, so by transferring to right side, we are having these values in the denominator. For this transfer function, we have to draw the direct form 1 structure here. So that we all know about the basic structure of direct form 1. By using that basic structure, we have to draw this direct form 1. So x of here input is x of z and output is y of z. So we have to draw numerator first, where numerators are zeros, denominators are poles. So we have to draw zeros first. So 3 is a common term without any functions. So 3 is here. If it is 1, we have to draw this arrow and put 1 here. Then 3.6 z inverse. We have to draw z inverse, then connect it to the next one and have to write the 3.6 here. Then 3.6 z power minus 2. So we have to draw another z inverse. This the combination of z inverse and this z inverse becomes z power minus 2. So then we have to write the zero point 0.6 here and to connect it with this. Then denominator is poles, so we have to draw one like this. Here one is there, so one is here. If it is one or two or any number, we have to draw this arrow and put it that number there. Then point 1 z inverse. Point 1 z inverse is here becomes minus 1 point, minus point 1, where this arrow is in this direction, so you have to put minus for this direction. Then we have to convert minus to plus and plus to minus. Here plus zero point 0.1 is at inverse, so we have to write minus zero point 0.1 here. Then zero point 0.2 minus zero point 0.2 is at inverse becomes plus zero point 0.2 is at inverse. So this is at inverse and this is at inverse combines each other to produce z power minus 2. This is the direct form 1 structure for this given system function h of z. Then direct form 2 structure. In this structure, we have to draw the denominator first and then numerator. Denominators are poles and numerators are zeros. So common z inverse is, we have to put common z inverse in this direct form 2. We all know about the basic structure of direct form 2. So by using that basic structure, we have to draw this direct form 2 also. So denominator has 1, so here we are putting 1. Then minus zero point 0.1, there minus zero point 0.1 is here, we have to write as it is the denominator. So we are putting minus zero point 0.1, then 0.2. Here numerator has 3, so we have to write 3 here. Then 3.6 here and zero point 0.6 here. See, this common Z inverse is shared with both numerator and denominators, and this Z inverse also combined with this Z inverse. So this is the direct form 2 structure for the given h of Z. Then cascade form. Cascade form. In this cascade form, we have to use the factorization. So to use factorization, we have to take the h of z, this equation. This equation is found by step 1. So this, to modify this equation for using the factorization method. So here in the numerator, we have to take z power minus 2 as a common one. Then this term becomes 3z square plus 3.6 z plus zero point 0.6. Then here also we have to take z power minus 2 as a common term. Then this term becomes z square minus zero point 0.1 z minus zero point 0.2. Then this uh, this z inverse goes up, then it becomes z power plus 2, then z power minus 2, then this term comes as it is, this also comes as it is. By by cancelling this two z power minus 2 and plus 2, the remaining terms becomes like this. Then by using factorization method, we are obtaining the z. Then by using the factorization method, we are obtaining this h of z as this term. Then by using calculator, we can obtain this answer. So first step is to set the calculator in radian form. Then press equation. Then go degree. Degree here is 2. So we have to choose 2. Then we have to we have to enter these values as a, b and c. Here a is 3, b is 3.6 and c is zero point 0.6. So uh, for a we have to enter 3, for b we have to enter 3.6, for c we have to enter 0.6. So we are getting x1 as minus zero point 0.2, then x2 as minus 1. So we have to write the opposite sign of the obtaining answer. So for is x1 equal to minus zero point 0.2, we have to write z plus zero point 0.2. Then x2 equal to minus 1, we have to write z plus 1. Then for denominator also we have to use this form method, this type of method. So a is here 1, then b is minus zero point 1, then c is minus zero point 0.2. So we are getting x1 as zero point 0.5 and x2 as minus zero point 0.4. So we have to write z equal to z minus zero point 0.5, then z plus zero point 0.4. Here also we are taking z as a common one. So here z is taken as common, here also z is taken as common. This z and z combining with each other and produces z power 2, z square. This also combine and produce z square, then this get cancelled. So the resulting solution is h of z is equal to 1 plus zero point 0.2 z inverse divided by 1 minus zero point 0.5 z inverse, then into 1 plus z inverse divided by 1 plus zero point 0.4 z inverse. For this h of z, we have to write the cascade structure. We are already know about the basic cascade structure. By using that structure, we are drawing this structure. So input is x of z and output is y of z. Then z inverse is uh, z. Here two terms are there. It is taken as h1 and it is taken as h2. It is considered as h2. So we have to draw this h1 as first. Then for by using cascade method, by cascading this h2 as second term. Then for h1 there is only one z inverse. So z inverse is written as common one. Then numerator denominator is first right return. So denominator is minus zero point 0.5. For the arrow is like this, so it is a plus zero point 0.5. So then it has 1, and here also we have to write 1. For numerator we have to write 1, then zero point 0.2. This arrow is like this, so we have to write as it is 0.2. Then for this h2 we have to write denominator first. For denominator it has 1, so we have to write 1 here, then zero point 0.4. The arrow is like this, so plus zero point 0.4 becomes minus zero point 0.4. So it has only one z inverse. So z inverse is common for both numerator and denominator. For numerator we are having in here 1 and it is 1 z inverse. So here is 1, here also we have to write 1.